So, but for the regular equations in exam, normally we don't use this part for the exam because this is normally coming for pipeline application. And the pipeline applications, there is no storage happen inside, no accumulative water inside, no missing water. The water going to the pipe or the network, it should be go out from the network. So the term of d by dt mass control volume for almost application in the exam coming, it is equal to 0. So we don't use. The only two terms used, sum of mass of flow rate out, it is minus mass of flow rate n equal to 0. In case of this is equal to 0, so I can put this another side. So mass out is equal mass in. It makes sense. If there is nothing happen inside the system, so any mass out, it should be going in. Sorry, any mass in, it should be going out. Okay, fine. So final equation for this, what we'll see for final equation, we'll find the final equation, sum of mass flow rate in is equal sum of mass flow rate out. Okay. Why we sum here? According to network, as we know, pipeline is a network. Not all the time is one input, one output. Sometimes we have two input, three output. Sometimes we have three output, three input, according to the problem and the equation. Okay. The simple problem, one input, one output. Okay, this is a simple problem. So for this case, for example, as here you see in the figure, we'll find mass n is equal mass out. M dot mass flow rate. Mass flow rate in equal mass flow rate out. Let's find this point. Okay, what does mass flow rate represent? Represented for rho VA. Rho VA. What is rho? Density. What is V? Velocity. What is A? Is area. So rho VA is equal rho VA. That's fine. Okay, for the cases of problems, application related for fluids, which is type of the fluid here is liquid. Normally the liquid it is incompressible flow, so the density normally considered as a constant. So for the cases of constant density, what happened? We'll find the density here for this one. It's cancelled with the density for other side. So what's remaining? Velocity times area is equal velocity times area. So velocity times area is equal velocity times area. What is velocity times area? Is said what is said discharge or volume flow rate.
Discharge.
Yes, volume flow rate or discharge. This is a very, very important part. Discharge or volume flow rate. Here you can see. Yes. Sum of Qn is equal to sum of Q out. That's fine. What's Q? Is AV, which is I said here happy phase. Don't forget, please, it's coming a lot, not a lot, always coming in the exam. Okay, Q is equal AV. Okay, this first point, the equation. Second point is important here for this slide, also the units. He play a lot here with you for the units. M dot is a unit of mass flow rate, which is, for example, kilogram per whatever the unit of the time, which is second, minute, hour, all is accept. British, it is slug per second, slug per minute, slug per hour. And also we can find pound mass per second, per minute, per hour. But Q have a lot of types of here formula of units, like what? CFM. What's CFM? Cubic feet per minute, cubic feet per second. What else? LBM. What's LBM? Liter per minute, liter per second, LBS. What else? We can found meter cube per second, meter cube per minute. What else? GBM, gallon per minute. So I have a different and a lot of types of equations, so units here. Okay. Okay, fine. An ideal flow of any fluid must fulfill the following. No idea? Continuity equation. Let's solve together this problem. Just I give you 1 minute for reading, or 30 seconds for reading is enough, but 1 minute for solving. Try to solve it, please, by this equation, using this equation. Q in equal Q out, but we can set sum because maybe more than one input or one output. and Q itself is equal AV. Just I give you 1.5 minutes, 30 seconds for reading and 1 minute for solving. The figure below shows water that's flow in from two pipes and exit from another pipe. The velocity of flow feet per second in the 12-inch inner diameter pipe most nearly. Let's see together how to solve this problem. According to the equation here, sum of Qn is equal sum of Q out. So we have to input, this is input 1, this is input 2, and this is exit, we can set 3. So Q1 plus Q2 equal Q3. Q1 is equal what? A1 V1 plus A2 V2 equal A3 V3. That's great. Here he give you the area by diameter. He give you diameter for each one. What is that area? Area is equal to pi over 4 d square. So we write it here, pi over 4 d1 square v1 plus pi over 4 d2 squared v2 equal pi over 4 dc square v3. So as we see here, we can find what pi over 4 is common. So we cancel pi over 4 from all terms. Remaining is diameters and velocity. Let's go to substitute it for this point. D, diameter 1 is 10. So 10 square, 10 inches square, V1, which is 1 feet per second, plus D2 square, which is 5 inches square, V2, which is 10 feet per second, D3 is 12 inches square, V3. Any problem here for this equation before we continue? One concern here, the unit of diameter is inch, the unit of velocity feet per second. So engineer said me, please change this to inch, to feet. So this should be by 12, by 12, by 12. As you see here, this conversion, it will be happening for all terms, correct? So what you will do in all terms, which is mean, this it will be 12 square, and this 12 square for all terms, which is can be cancelled again without any headache of more calculation. So for this case, especially for something like this, it's okay, no problem, because the term here is inch square feet per second, inch square feet per second, inch square feet per second. So the unit is balancing. So continue according to the balancing now for the units. This is 10 square, which is 100, plus 5 square, 25, plus multiply 10 with 250, equal 12 square root 144, V3. So we'll found V3 finally is equal 350 divided by 144, which is equal to what? 2.4. Any question here? Any question? I see some engineer going out and going in and so on. So you have a problem for the network or whatever, or you have something? Any issue? Any issue? Okay. Bernoulli equation. Bernoulli equation, this is the second equation important actually. What is Bernoulli equation? Sorry. Bernoulli equation is one of the equations related for energy. We study here energy, but we study energy in ideal form, ideal case. Okay, so this equation describes the energy along a streamline. Along what? Along a streamline. Sum of total energy along the streamline is constant. Sum of total energy along the streamline is constant. But what is this energy? Energy here consists from three terms. What is this three terms? The first term is flow energy. Second, potential energy. Third is kinetic energy. So again, what is the terms here for the energy? Flow energy, potential energy, kinetic energy. And this sum of these energies is equal to constant. So the energy along the streamline is equal to constant. The first two terms here is related for piezometric. Okay, piezometric head. But what's head you talk about for energy here? Yes, exactly. Actually, the form of energy, I can describe it as the energy, which is unit of energy for each term. This is joule, joule, joule. And I can describe it also by head, which is here, head, like meter, meter, meter. Really? Yes, same like pressure. Sum of pressure, I can set this pressure is 10 psi or 3 bar. That's fine. Or you can set the pressure here, describe it by head. This pressure for this pump is 20 meter head. 20 meter head, this is pressure? Yes, because the head is just multiply for one of constant here, poverty, gamma, specific weight. You got it what? You got it the pressure. Okay, so the pressure or head refer to the same point. Here's the same. We can represent for energy equation by joule or you by head, by meter or whatever, feet or inch. Normally, the problem in the exam, we solve it and use it this shape of or this form. Normally, this is not used before in the equations. This is normally used. Sometimes in a little cases, we use it pressure form. We have another form for this. Yes, but all describe the same point, the same thing. All describe the same something, the same energy, Bernoulli equation, energy in ideal case, all represents the same thing. Okay, so I need to show what is the form of the head. The first term here, B over gamma, because to be in head form, just to divide the energy form here by G. So this is first term by G, it will be B over gamma. Second term by G, cancel G, it will be Z. Third term by G, it will be V square over 2G. I prefer to write it up like this. So B over gamma plus Z plus V square over 2G equal to constant. What is referred to this? The first two here terms, it is piezometric head, both together. Piezometric head, or we can say H static head. Plus the second term here is velocity head or dynamic head. So static head plus dynamic head is equal to constant, which is equal to total head. Static head plus dynamic head equal what? Total head. Equal total head. This is the form of the energy, Bernoulli equation, but in shape of head form. We can use it the same point here, but in pressure form, it will be like this, P over, not over something, this is B alone, plus gamma Z, plus V square over 2 rho, correct? No, not like this, just a minute. Last term change. This is not true. Because you multiply the equation of energy for density. If you multiply here density B, density gamma Z, density rho V square, yes, rho V square over 2 equal to constant. This is a form of pressure. So the first two again here, this first two is piezometric pressure. This is dynamic pressure here, and the final here, this is the total pressure. Now we study Bernoulli equation. Now we studied continuity equation. These two equations together, many problems in the exam coming to apply for these two equations. Sometimes the problem need to apply both equations. First one in the first step, for example, and use it for the second step, another equation. It's like supported equation, okay? Something required for Bernoulli, but we need continuity as a support equation to can solve for Bernoulli. That's great. Bernoulli equation is based on the assumption that any idea? All of the above. Euler's equation. Euler equation, one of the equation describes the energy, same like Bernoulli, but Bernoulli normally used for a long streamline. And actually the problem in exam, it's coming related for Bernoulli because easy for substitution and so on. No directions and affect for the problem. It's like not vectors or something like this. But Euler's equation, just we understand the meaning, or it's used also for energy, but normally used to study exactly the pressure variation in different points for the body you study, okay? But not easy for the numerical part, so we don't study and present for this part for the numerical because it's not coming for the exam, the numerical part. Okay, this is fine, but just at least to understand, this is used for pressure variations, calculation, and use it for conditions of the flow in viscid and in compressor. Static pressure is the pressure of flowing fluid at any point. This is static pressure. And pressure tab, it is a small hole in the pipe. Here, differential pressure meter. What is this? This is different devices used to measure a pressure. Velocity. Different devices to what? Using or measuring the velocity. Depend for what? Depend for velocity. It means I measure pressure, and according to pressure measurement, I can calculate the velocity. It's not measure the velocity direct. No, I use some equation relations, function for pressure, and this pressure I can read it from these cases or application. Okay. These cases here, I show the three types or three cases. The first one is orifice. This is one. The second one is venturi. The third one is nozzle. The three types here, the first time and second time, third also. The three types here is measure and calculate the velocity with the same concept. What is this concept? Just I need to measure the pressure, static pressure for two different locations or two different positions. These two different positions at two different diameters. At two different.
So audio video is not matching.
What?
Your video is staying at Bernoulli equation, and audio it's you have class 3 4 slide more.
For again, for what? I can't hear you.
Yes, I'm saying a slide is showing Bernoulli equation for me, and it's you have discussed 3 4 slides more.
Actually, there is a delay between your video and audio. Your audio is back and your video is very back. Your audio has passed 2 3 slides.
That's for him, for not for me.
Yes, that is the reason. Now you are discussing venturimeter like orifice, but
This
still
is
is
delay
showing
in
Bernoulli
video.
equation.
Delay in video with me.
Yeah.
I
Your
don't know
video.
what. Yes, now we reach at this point.
Now it's fine.
Yes, now fine.
And before, up to here, for example, here is fine.
Yes, it's fine.
Okay.
Now audio video are at same point, right?
Voice is. Okay. So here, this is the three types here for the orifice and for venturi and for nozzle. What is the concept? I measure the pressure for two different positions. These two different positions, it's at different diameter conditions. Like, for example, this diameter, regular diameter. So I make something to reduce the size or the diameter for the flowing of the fluid. So, for example, here for the first type is orifice. Just I put here something like this orifice. This way make what? The normal diameter like this. What happened due to the orifice put it here? I make something reducing of diameter, reducing of diameter. So what is the idea for that? Let's see. You have two points here, one for the continuity and one for Bernoulli, correct? Continuity said what? Said Q is equal AV. That's great. And the Bernoulli said what? B over gamma plus Z plus V square over 2G equal constant. That's great. Which is mean we have a function between the static pressure. This is static pressure. You can read it from the experiment. And this is what dynamic part. That's great. If the velocity term here, dynamic part, it change. What happened for the first part? It's also change. In opposite, if the first part it changed, what happened for the second part? Also change, because both at the end is equal, constant. That's the first point. Second point here, the velocity and the area is inversely proportional together, which is, and also both at the end is equal Q, and the Q is according to conservation of mass is constant. It means the flow in here from this side for the pipe, it should be go out. So the flow not change, which is mean AV is constant. So if a change happen for area, velocity for sure it changed. This is the concept here for using. What is the concept? I make different diameter. So if you make different diameter, so you obtain different velocity. It means this is velocity change for the case 1 and case 2. So what happened for the pressure? It changed also. What happened for the pressure? It changed. I'm going to read the piezometric pressure for the first case for a regular diameter, and I read the pressure for the second case at the contraction happened by orifice here, for example, here by contraction of the pipe itself, here by contraction by adding nozzle. So the idea at the end is the same. Make a contraction for the size of the diameter, which to obtain one regular diameter and one is less for this diameter. And what next? I measure the static pressure for the first case and second case. I measure the static pressure here for the tube, and I measure the static pressure here, static head, okay? Static head of the pressure. So what else? If you measure the static, now you measure the static head, H static plus H dynamic equal constant, fine. H static, you read it for the first case. That's great. So you can set B over gamma plus Z plus V square over 2G. This is already, you can read it from the figure or the experiment. That's great. It should be equal the second case, B over gamma plus Z plus V square over 2G for the second case. For what is this? This is the reading from the second case. So this is first case, number 1. This is the second case. This first case, the second case, and so on for the third one. First case, second case, which is piezometric pressure 1, piezometric pressure 2. I read it from all these experiments, whatever, orifice, venturi, or nozzle. So this is you have, this is you have. This is 1, this is 2. And what is this? This is velocity for the case 1. This is velocity for the case 2. Now, what is the unknown for this equation? V1 and the V2. V1 and the V2, both is unknown. So I need supported equation to get a relation between the velocity 1 and the velocity 2 to support and substitute for this equation. What is the supported equation? We can use it. This is one. We can use it Q. So we can use it Q1 equal Q2, continuity, set that, conservation of mass. So Q1 is A1 V1 equal A2 V2. Diameter for the first one and diameter for the second one is already we know, is given. So what is the unknown V1 and the V2? So we can get a relation between velocity 1 and we gonna get between velocity 1 and velocity 2. We can set velocity 2 is equal area 1 by area 2 V1. This is relation, correct? Take this and substitute in the first equation to obtain one equation in one unknown V1, which is required. This is the velocity required. This is we needed in the exam as I discussed with you now. No, for this type of the problem like this, for the orifice venturi and the nozzle, normally the equation for the velocity is given direct. Why I presented this deducing and everything to understand the concept first. Second point, because the equation, if you don't understand what is this parameter or variables in the equation, you're going to substitute wrong. Let's see, for example, this I will choose the final equation for the velocity. So if you don't understand what's P1, what's P2, what is area, refer to what is rho, rho for what, rho for manometer or rho for flow, which rho? So it is important to understand what is each term refer. For example, this is rho for the equation itself, which is rho for flow. Okay, delta B1 minus B2, I can't get it direct. I can get the difference between the two pressure, which is H. So this, it will be reflect gamma H. Which gamma? The same for the flow? No, this is gamma for manometer, for example. This is the little notes it should be aware. Okay, so the problem for the exam for these types, so whatever nozzle, venturi, and orifice, and normally coming for venturi like this, it should be given equation like this to substitute. The other type is bitted tube. Bitted tube, this is the second type of measurement of velocity. I think it's not mentioned here. This is bitted tube. What is referred to bitted tube? Bitted tube is can measure the velocity by one device direct. Okay, something like this, or I will present first is the basic of this because it is coming also in the exam. Just 1 minute, I will show you. Let's see with me. Okay, this pipe duct, okay, and this duct I have two pipes, this pipe here, and this is another pipe. You tell me, is this not continue? No, it's continue, but in the back side not showing.
Excuse
So both
me.
is measure what?
Even now there's a delay.
Now you have a delay.
Yeah, even
Okay,
for
just
last 5 minutes
maybe
also there is delay.
because I open
There's no
another
delay in
page.
your audio. Only your video is delay.
Yes, it's okay. Now it's fine. It's open or not?
And now the drawing came.
No, I open whiteboard. This is open with you.
Yeah, the whiteboard like it opened after a 10-second delay.
Okay, no problem. Fine. I will consider that. No problem. I continue now.
Yeah.
Okay, the flow is moving like this in this direction. What happened? The flow during the moving here, the flow is raises due to the difference pressure inside and outside. But what we'll see, we'll find here, this is raised something like this. And this is raised something like this. Wow. Both in the same flow. So what's different? Yes, let's see. 1 and 2 is almost along the streamline. Consider like that. That's fine. Both in the same level. No problem. So what is different reading between 1 and 2? Point 1 is clear, is measure static, same like what I present to you in the venturi, orifice, whatever. This measure is static, no problem for that. So the first point is static, be static. Or I can say actually, H is static because this is measuring as a head. H is static. That's great. What is here for the second tube? Measure what? Actually, for the first point, the flow is not affected, it's still moving. Moving, no problem. But for the second case, no. What happened for the second case? Actually, for the second case, something happened. What is this? Happen is what? Stagnation here. You see this? Exit. This is input to the tube. Yes. The flow here is stagnant. The flow here is what? Is stagnant. What's meaning of stagnant? Stop. Flow stop? Yes. The flow is moving above and down. But at this point is stop. Stop, it means no kinetic energy, no kinetic energy. But as we know, energy, it can't lose it like this. It should be converted from one side to another. Yes, so represented as what? Represented here or reflected here as a head. What's it mean? It means the first part on the same level like this, the first part here, this first part, correct? The first part here, as usual, is represented static, no problem. But the remaining part here represent for dynamic. Really? Yes, because here this is due to stagnation happen for the flow. This is energy, converted from kinetic to another shape, another form. So is reflected and converted to head. So the second part here dynamic. It means one column here refer to static, but the other column it refer for both static and dynamic. What is static and dynamic? This is total. So what is said for this device? Beated tube. So beated tube is measure one column, one pipe measure static, and the other one is measure total. This is easier to get the velocity by easy way. And this is coming in the exam, same like this problem exactly. And they need from you to deduce the equation. It's not like Venturi and something like this, give you V is equal blah, blah, root, blah, blah, and just continue substitution. No, it should be deduce the equation, which is meaning write the equation, H static plus H dynamic is equal H total. That's great. H static is give you as a reading from here. For example, is 2 inch plus H dynamic, which is unknown. Why unknown? Because he give you the other pi, which is, for example, 12 inch. So this is 12. So H dynamic, it will be at the end is 10 inch. This is the required? No, this is not the required. The required for this problem in the exam is velocity. How to calculate velocity? I know the original equation is b over gamma plus z plus v square over 2g equal to constant. What is this first term? Static. What is second term? Dynamic. So I needed here H dynamic 10 inch equivalent to what? V square over 2g. So you already deduce another equation function for velocity to get what? To get the velocity direct. So velocity, it will be equal root 2g 10 inch. So finally, I needed to substitute G. G is what? 9.8. No, this is British. So it should be substitute here for the velocity. Root 2 multiply 32.2. This is feet per second square. So this 10 inch divided 12 to change it from inch to feet and get it the value. This is one of the problem coming in the exam with this number. The same number? Yes, with this number coming. Okay, so take care from this, please, and try to check it and solve it again to be sure you are understanding and everything is clear. Any question here?
So how you take this as a stagnant? Either this end is open or closed.
No, this
Or
not closed
second,
pipe, but the L shape is make stagnation for the flow. So the flow going in for the L shape, the flow is instant stagnation. So at this moment, velocity is equal to 0. So the energy for this converted direct to head.
no,
Fine.
if velocity is zero, if velocity is zero, then how liquid will raise in the tube?
If what?
If this end is open, with some velocity liquid will raise in the pipe or tube, whatever we consider this one, L shape, then how we take it as stagnant?
What's meaning of how ticket is stagnant? This is a device. It is a device. We don't change for the shape of the
Yes,
device. This is a device used to calculate the velocity. So we make it and manufacture as it is. One pipe is long pipe straight, and the other one pipe is L shape to create a stagnation or to obtain a stagnation.
this straight pipe, it is inserting inside the liquid or it's just like welded on the boundary of the pipe.
For the other one, no problem. It's same like the L shape. Both is measured from the same point, the same level.
Right, means both are entering into the pipe.
Yeah, but not affect for the first pipe, not affected for the flow, not make stagnation. The second pipe is make stagnation.
Then liquid will rise in the both of them, right?
Yes, but first one is
Uh,
just reflect the static pressure.
yes, but for liquid to rise, liquid will have some velocity, then it will rise.
Again,
Liquid will rise if it will have some velocity, right? inside the
Liquid is rise
L-shaped tube.
if you have what?
If it will have some velocity, with some velocity, it will move, then it will rise, right?
What's meaning of some rise? Liquid is rise due to the difference between the pressure inside due to movement and the pressure outside for the atmospheric. This is the reason for
Like
the
this.
upcoming of the flow go up.
Yes, definitely. Liquid will have some velocity because of which it will rise in the tube.
Yes, it is rise in this tube.
So it has some velocity. Then how we consider it as stagnant?
For the second pipe,
Yes, for the second pipe.
for the where is the signal? This is the signal coming. This is the signal coming from here. So at this signal coming, it is already here, make a stagnation, stop the flow. Not like this. This not affect for the dynamic of the flow. The flow is moving, but signal go up due to the difference pressure. I don't go for the to the pipe and rotate to go the flow up. No. Just is automatically flow go up due to the difference pressure. But for the second case, no, the flow is stopped here. You make stagnation for the flow. How to raise it this? Due to both. First one is going inside with a regular static pressure. So it goes the distance for the static. And due to the stagnation, all kinetic energy due to this movement also converted to height. So you will found instead of a small distance same like the first pipe, it is large distance reflected to both static and dynamic. That's fine.
But in the second pipe will be more than first one.
Again,
L type, this pipe will be more than first one. That is
yes,
measuring
yes.
height static. Okay.
This is also bit tube, but we combine the two pipes inside. It means this device here, I put the two pipe together, like outer pipe and inner pipe. So what happened? The flow is moving. Yes, this two pipes, you have two source of inputs. One in the inner of the inner tube. This is the first one here. Okay, inner tube. Okay, the flow in the inner tube. This is which type? For sure, this is the one for stagnation flow. This is the one for what? Stagnation flow. So the inner tube reflect for what? Inner tube reflect for the total. Reflect for what? Total. What else? The second one. The second one here in the outer pipe. You see, in the outer pipe, like this is the outer pipe. Here we make holes. This is the outer pipe. Here is make what? Holes. Holes of what? Holes around the circumferences. Holes around circumferences. It means holes around the circumferences for this circle. For this what? Circle like this. Holes. If you check the elevation front view. So what else? The flow during the movement like this. Some of this signal going inside like this here and go through in the annular between the outer tube and the inner tube and measure what? This is reflect to static. Why? Because no stagnation for the flow. So we have two source of input, one from the holes in the circumferences of the outer tube, which is going inside this tube and move between the outer and the inner tube in the another point. Okay, so this is one reflect to static. The other one in the middle, in the inner tube, this is total. That's great. This problem give you the density for the flow, which is here is air, and they give you also density for the manometer, which is water, and they give you the reading for the difference between the signal and this signal. They give you the delta H. That's great. Where is this data? Yes, this is the density for the water, raw water, 10 to the power 3 kilogram per meter cube. And they give you the reading from the manometer, 10 millimeters, so delta H 10 millimeter. And they give you rho for the flow, which is air. This is 1.2 kilogram per meter cube. What is the required? He requests here the velocity. He requests here what? The velocity of air. So how to calculate the velocity of air? He give you equation here for the velocity of air. According to the previous equation we already presented in the whiteboard, velocity, it should be equal root 2 g and h, which is, for example, for the previous question I gave to you, is 10 inch. What is different here between this case and this case? I tell you, the previous problem in the whiteboard I presented to you, both tube, I put it direct inside the flow, correct? Yes. And there is no another different fluid in the manometer or raising fluid. The flow in the normal pipe is the same flow inside the duct, and the flow in the L-shaped pipe is the same flow in the duct, correct? Remember, it's something like this. Pipe like this and pipe like this. What is the flow here? And what is the flow here? The same flow inside here. This problem different. What is different? The manometer reading is used another flow. This is air, but this is water. This is air, but this is what? This is water. So the effect for the density for water and air is effect for the equation. Here the same flow, so there is no effect for density. Here we have effect for density. So it should be this, put the ratio between densities. This is what happened for this equation. All in all, to don't confuse, for the first problem we solved in whiteboard, coming in the exam and should be deduce the equation to bring this equation or save this equation at the end to substitute direct. Any other problem coming, it should be give the equation. For example, a Venturi should be given the equation. Equation like this should be given the equation. So any equation not direct, it gives you the equation. But what is the important? Understand what is term here refer to, substitute it easily. For example, here is a velocity, I'm going to substitute direct. 2, yes. Gamma manometer, what is gamma manometer? Water, so rho G, rho 10 to the power 3, G is 9.8. Delta H, 10 millimeter, times 10 to the power minus 3 to be meter. Rho flow, 1.2. That's it, fine. Only that, just direct substitution, but take care for units. That's it. Cancel 10 to the power 3 with 10 to the power negative 3 and continue solving by calculator. You obtain the answer is 12.8. Great. That's fine. Laser Doppler anemometer is used to measure
It is measure velocity.
is velocity exactly. According to equation of continuity, any idea? Any idea? Continuity.
Actually, yes.
A1
Audio video are
V1
not at the same time.
equal A2 V2. Pressure less than atmospheric pressure is known as, again, pressure
Suction.
less than atmospheric pressure.
Negative gauge, suction, vacuum.
This is negative gauge. and also vacuum, and also suction. So all of this. Below atmospheric, I said vacuum or negative gauge, or sometimes suction. Affinity law. Actually, affinity law, one of the laws is applying for some problems. It's coming also in the exam in different times, related for any equipment, rotating equipment like pumps, like fans, like compressors, any something rotate. Okay. This relation actually between the flow rate and the speed, or pressure and speed, or power with the speed. And also similar to these relations, we have the same parameters like flow, pressure, power with diameter. But normally in exam, it's coming with relation with speed. But if it's case of coming to diameter, no problem. The same relation here is applied for diameter. But normally in exam, coming with relation with speed. Another point to don't save a lot, just to save it with intelligent way. How to do that? Actually, this is direct relation, which is Q2 by Q1 equal N2 by N1. That's it. Finished? Yes. Pressure, the pressure use the same relation, but just add square. Power, the same relation, at cubic. Like P2 pressure by pressure 1 equal N2 by N1, but just add square. And power, this is power 2 by power 1 equal N2 by N1 cubic, not more. Read this please together and going to solve it. I write it the equation to you here to just try to solve. This is power, so power 2 by power 1 equal N2 by N1 cube. Anyone got answer? Okay. No one. Power 2, he give you what is a given? Power 1, 1000 horsepower. RPM for 1750 RPM. Into 1000 RPM. So power 2 required by power 1,